Section 5.7 Introduction to Square Root. In this video, we will see how the square of a number is defined and how to take the square root of a whole number, how to use radical notation to express the square root of a number, how to find the square root of a fraction, how to find the square root of a decimal, and how to estimate square roots. Recall that x squared equals x times x, the square of a number. The number x squared is called the square of the number x. Thus, for example, 9 squared equals 9 times 9 equals 81. Therefore, the number 81 is the square of the number 9. Negative 4 squared equals negative 4 times negative 4 equals 16. Therefore, the number 16 is the square of the number negative 4. In the margin, we place a list of squares of the whole numbers ranging from 0 through 25, inclusive. So, on the left, we have some x values, and on the right are those values squared. So, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. Square roots. Once you have mastered the process of squaring a whole number, then you are ready for the inverse of the squaring process, taking the square root of a whole number. Above we saw that 9 squared equals 81. We called the number 81 the square of the number 9. Conversely, we call the number 9 a square root of the number 81. Above we saw that negative 4 squared equals 16. We called the number 16 the square of the number negative 4. Conversely, we call the number negative 4 a square root of the number 16. Square root. If a squared equals b, then a is called the square root of the number b. Example 1. Find the square roots of the number 49. Solution. To find a square root of 49, we must think of a number a such that a squared equals 49. Two numbers come to mind. Negative 7 squared equals 49, therefore negative 7 is the square root of 49, and 7 squared equals 49, therefore 7 is the square root of 49. Note that 49 has two square roots, one of which is positive and the other one is negative. Example 2. Find the square roots of the number 196. Solution. To find a square root of 196, we must think of a number a such that a squared equals 196. With help from the list of squares, two numbers come to mind. Negative 14 squared equals 196, therefore negative 14 is the square root of 196, and 14 squared equals 196, therefore 14 is the square root of 196. Note that 196 has two square roots, one of which is positive and the other one is negative. Example 3. Find the square roots of the number 0. Solution. To find a square root of 0, we must think of a number a such that a squared equals 0. There is only one such number, namely 0, hence 0 is the square root of 0. Example 4. Find the square roots of the number negative 25. Solution. To find a square root of negative 25, we must think of a number a such that a squared equals negative 25. This is impossible because no square of a real number, whole number, integer, fraction, or decimal can be negative. Positive times positive is positive, and negative times a negative is also positive. You cannot square and get a negative answer, therefore negative 25 has no square roots. Radical notation. Because negative 3 squared equals 9 and 3 squared equals 9, both negative 3 and 3 are square roots of 9. Special notation called radical notation is used to request these square roots. The radical notation, pronounce the non-negative square root of 9, calls for the non-negative square root of 9. Hence, the non-negative square root of 9 equals 3, the positive 3. The radical notation, pronounce the negative square root of 9, calls for the negative square root of 9. Hence, the negative square root of 9 equals negative 3. Radical notation. In the expression, the symbol is called a radical, and the number within the radical, in this case, the number 9, is called the radicand. For example, in the expression non-negative square root of 529, the number 529 is the radicand. In the expression, the non-negative square root of a squared plus b squared, the expression a squared plus b squared is the radicand. Radical notation and square root. If b is a positive number, then the calls for the non-negative square root of b, and calls for the negative square root of b. Note, non-negative is equivalent to saying not negative, i.e. positive or 0. Example 5. Simplify a, the square root of 121. Referring to the list of squares, we note that 11 squared equals 121, and negative 11 squared equals 121. Therefore, both 11 and negative 11 are square roots of 121. However, the square root of 121 calls for the non-negative square root of 121, thus the square root of 121 equals 11. B, the negative square root of 625. Referring to the list of squares, we note that 25 squared equals 625 and negative 25 squared equals 625. Therefore, both 25 and negative 25 are square roots of 625. However, a negative square root of 625 calls for the negative square root of 625. Thus, negative square root of 625 equals negative 25. C, the square root of 0. There is only one square root of 0. Therefore, the square root of 0 equals 0. Example 6. Simplify a, the negative square root of 25. Because 5 squared equals 25 and negative 5 squared equals 25, both 5 and negative 5 are square roots of 25. However, the notation negative square root of 25 calls for the negative square root of 25, thus negative square root of 25 equals a negative 5. B. Square root of negative 25. It is not possible to square a real number, which is a whole number, integer, fraction, or decimal, and get negative 25. Therefore, there is no real square root of negative 25. That is, the square root of negative 5 is not a real number. It is undefined. Order of operations. With the addition of radical notation, the rules guiding order of operations change slightly. When evaluating expressions, proceed in the following order. 1. Evaluate expressions contained in grouping symbols first. If grouping symbols are nested, evaluate the expression in the innermost pair of grouping symbols first. 2. Evaluate all exponents and radicals that appear in the expression. 3. Perform all multiplication and divisions in the order that they appear in the expression, moving left to right. And 4. Perform all additions and subtractions in the order that they appear in the expression, moving left to right. The only change in the rules is in item number 2, which says evaluate all exponents and radicals that appear in the expression, putting radicals on the same level as exponents. Example 7. Simplify negative 3 square root of 9 plus 12 square root of 4. Solution. According to the rules guiding order of operations, we must evaluate the radicals of this expression first. So evaluating the radicals, square root of 9 is 3 and square root of 4 is 2. Then multiplying, negative 3 times 3 is a negative 9 and 12 times 2 is a positive 24. So negative 9 plus 24 is positive 15. Example 8. Simplify negative 2 minus 3 square root of 36. Solution. According to the rules guiding order of operations, we must evaluate the radicals in this expression first, moving left to right. So square root of 36 is 6. Then multiplying, 3 times 6 is 18. Then subtracting from left to right, negative 2 minus 18 is negative 20. Example 9. Simplify a, the square root of 9 plus 16. And b, the square root of 9 plus the square root of 16. Solution. Apply the rules guiding order of operations. A, in this case, the radicals acts like grouping symbols, so we must evaluate what is inside the radical first. The square root of 9 plus 16 equals the square root of 25 equals 5. B, in this example, we must evaluate the square roots first. The square root of 9 is 3 and the square root of 16 is 4, then 3 plus 4 is 7. Fractions and decimals. We can also find square roots of fractions and decimals. Example 10. Simplify a, the square root of 4 over 9, and b, the negative square root of 0.49. Solution. A, because 2 over 3 squared equals 2 over 3 times 2 over 3 equals 4 over 9, this means that the square root of 4 over 9 equals 2 over 3. B, because 0.7 squared equals 0.7 times 0.7 equals 0.49, and negative 0.7 squared equals a negative 0.7 times a negative 0.7 equals a positive 0.49, both 0.7 and negative 0.7 are square roots of 0.49. However, negative square root of 0.49 calls for the negative square root of 0.49, hence the negative square root of 0.49 equals a negative 0.7. Estimating square roots. The squares in the list of squares are called perfect squares. Each is the square of a whole number. Not all numbers are perfect squares. For example, in the case of square root of 24, there is no whole number whose square is equal to 24. However, this does not prevent square root of 24 from being a perfectly good number. We can use the list of squares to find decimal approximations when the radicand is not a perfect square. Example 11, estimate square root of 24 by guess. Use a calculator to find a more accurate result and compare this result with your guess. Solution. From the list of squares, note that 24 lies between 16 and 25, so the square root of 24 will lie between 4 and 5, with square root of 24 much closer to 5 than it is to 4. Let's guess. The square root of 24 approximately equals 4.8. As a check, let's square. 4.8 squared equals 4.8 times 4.8 equals 23.04, not quite 24. Clearly, square root of 24 must be a little bit bigger than 4.8. Let's use a scientific calculator to get a better approximation. From our calculator, using the square root button, we find that square root of 24 approximately equals 4.898979485557. Even though this is better than our estimate of 4.8, it's still only an approximation. Our calculator was only capable of providing 11 decimal places. However, the exact decimal representation of square root of 24 is an infinite decimal that never terminates and never establishes a pattern repetition. Just for fun, here's a decimal approximation of square root of 24 that is accurate to 1,000 places, courtesy of the following website. If you were to multiply this number by itself, square the number, you would get a number that is extremely close to 24, but it would not be exactly 24. There would still be a little discrepancy. Important observation. A calculator can only produce a finite number of decimal places. If the decimal representation of your number does not terminate within this limited number of places, then the number in your calculator window is only an approximation. The decimal representation of 1 over 8 will terminate within 3 places, so most calculators will report the exact answer 0.125. For contrast, 2 over 3 does not terminate. A calculator capable of reporting 11 places of accuracy produces the number However, the exact decimal representation of 2 over 3 is 0.6 with a bar over 6. Note that the calculator has rounded in the last place and only provides an approximation of 2 over 3. If your instructor asks for an exact answer on an exam or quiz, then being an approximation is not acceptable. You must give the exact answer, 2 over 3.